the last video that ended with this screenshot to give you a little preview of what we're talking about. So when we are talking the powers of I is just like any, well, it's not a variable itself, but it's treated like a variable when it comes to exponent, except for one thing. I must be written with an exponent of 1 in our final answers. We can work with powers of I, but I must be written as with an exponent of 1 in our final answers. My final answers can contain I, but they can't contain I squared, I cubed, I to the 4th, I to the 5th. No powers of no exponents except for 1. So I will always be written with an exponent of 1 in our final answers. So I to the first power, well, that's easy. I to the first power is I, because the I to the first power is the square root of -1, which we've already established is I. We've said already, if I give you the square root of -1 and I square it, because that's what I squared is, that gives us with -1. Well, what about if I have I to the third power? Let's keep this rule going. I to the third power would be the same thing as taking I squared and multiplying it by I. Because remember, our exponent rules, our product rule says if you have two bases that are the same base but with different exponents, we can just keep the base and add those exponents. So that's what I'm doing right now. I'm saying x to the third is the same as, or I to the third is the same as saying I squared times I, because 2 plus 1 is 3. So I squared times I squared is -1. -1 times I, that's going to give me -I. So anytime we have an I cubed, we're going to say -I. I to the 4th is I squared times I squared. Well, I squared times I squared, another way of writing that would be -1 times -1, which is +1. Boom. Well, what if we have more than the 4th power? What if we have the 5th, 6th, 7th, or 8th power? Glad you asked. We're going to take that same idea that we were just messing with, and we're going to repeat it. I to the 5th is I squared times I squared. There's I to the 4th times I to the 5th, 2 plus 2 plus 1, that's 5. That would be the same as -1 times -1, because I squared is -1, times I, which would give me I. I to the 6th could be I squared times I squared times I squared. Another way, 2 plus 2 plus 2, that's 6. Well, that would be -1 times -1 times -1. A negative times itself an odd number of times is always a negative. I to the 7th is going to be I squared, I squared, I squared. There's my I to the 6th times I. So -1 times -1 times -1 times I is -I. And I to the 8th, I squared, that's a square, I squared times I squared, which is the same as saying -1 times -1 times -1 times -1. A negative times itself an even number of times is a positive one. Boom. Did you notice that pattern repeats for 1, 2, 3, 4, 5, 6, 7, 8. That pattern repeats through infinity. We always go I, -1, I, 1. 1, I to the 1st, 2nd, 3rd, 4th. 5th, I to the 6th, I to the 7th, I to the 8th. I to the 9th, I to the 10th, to the 11th power, to the 12th power, to the 13th power, 14th power, 15th power, 16th power, on and on and on and on forever and ever and ever. So we have a rule. If to reduce this and make it a lot simpler, you could just repeat the pattern and keep counting until you get to the exponent. That's way too long. Just take the exponent and you're going to divide it by 4. The remainder is the power of I. The remainder is the power of I. And I to the 0 power, if the remainder is 0, I to the 0 power would have to be a 1. Now let's take a look. How's that going to work? So we have I to the 21st power. So since I'm looking for the remainder, I am going to do a little long division. 21 divided by 4. How many groups of 4 can I get from 21? Well, I can get 5 groups evenly with remainder of 1. So I to the 21st power can be rewritten as I to the 1st power, which is just I. Boom. That was easy enough. I would like you to try the same thing with this one. You go ahead and try this one, and I'm going to do this one with you right now with the negative exponent. Our exponent rules, all of them, even the negative exponent rules, still apply to the powers of I. So if we have I to the negative 14th power, I can rewrite that as I over 1 over I to the 14th power. So we're going to take our 14, and how many groups of 4 can I get out of it? Well, that's going to be 3 full groups, which would give me 12, and that would give me a remainder of 2. So another way of writing I over I to the 14th power would be rewriting it as I over I squared. Well, I squared, we know, is negative 1. And 1 over negative 1 is negative 1. Boom. Let me just show you something real quick with a different negative exponent. I am going to see you in class, but I actually want to try something first. What if I had given you like I to the negative 3 power? Let's give this a shot. Now we're going to do the same thing. We're going to follow our negative exponent rules. So that's going to become 1 over I to the 3rd. I to the 3rd, we know, is negative I. Because I to the 3rd, if you don't remember, is I times I squared. I squared is my negative 1 times I, negative I. Now we hate negatives in the bottom. So what we're going to multiply by is my conjugate. So I'm going to multiply both top and bottom by positive I. Not negative I, but positive I. So on top, I'm going to get 1 times I, which is I. And on bottom, I'm going to get negative. I times I is I squared. So that's going to give me I over negative 1, which would be I. So don't forget your negative exponent rules and multiplying by the conjugate. Please come to class with any questions that you might have, everybody, and I will see you when I see you.